This is part of the assignment for the course ME 760 at the University of Waterloo. We are covering mobile sources air toxics risk assessment. The segment for this lecture refers to air dispersion modeling, and I want you to practice using a simple program like Screen View and change stability classes and see what is the impact in the concentrations. To do that, we will start by clicking New, and we're going to give it any name. We will just say ME760. We click Save, and now it comes. If it is a stack, it's a point source. If we're using areas, say area source, volume, volume source, etc. We also need to tell the code if the source is in a urban environment or in a rural environment. What would change here would be things such as surface roughnesses. Cities are usually drier than rural areas, but it doesn't mean it's always the case because you could have desert as well. I'm going to do rural. I'm going to say emission rate grams per second. I'll put a high one here, 100 grams per second. I'll say stack is also 100 meters. Inside diameter, let's say it is 3. Exit velocity, and also do flow rates. Exit velocity, I'm going to say it is 20 meters per second. Exit temperature, I'm going to say it is 400 Kelvin. And we finish entering the data for the source. Now we're going to go to the next button here, and we're going to select it if it is flat terrain, simple, flat. We're going to say automated distance, so we'll create the receptors over the distance that we want to model. For our example here, I'll start with full meteorology. For the homework, we're going to do single stability class and wind speed. So here it is done. Anemometer height, it is usually 10 meters, and we are going to move to complex terrain. We said it's flat. Automated distances, we're going to do from, let's say, 50 meters to 2,000 meters. We do not have to do this because we said automated distances. We have no buildings to discuss. It's not a focus of this course since building downwash is only for point sources and we're dealing with mobile sources like area and volume sources. So they do not have building downwash. I will not cover. Fumigation is also for point sources close to large water bodies. We are not going to cover this here, but I wanted to show it to you. Now I'm ready to run. This is all you need to do. And I'll click Run. The project is complete, as you can see here. I'm going to click Run, and it's done. I will see the graph, and you can see the concentration has a maximum over here, about 1,000 meters, and then it drops. Now for the homework, we're going to go single stability class and wind speed. So if we say it will be A, very unstable, 10 meters wind speed will be, let's say, stability class say only at 3 meters. And then we say run, and run, show the graph again. And you see now that it is at about 700 meters, the maximum. You can even see this by looking at the output itself. You can navigate down and you see that simple terrain maximum concentration is 107.6 micrograms per cubic meter, distant to maximum 739. If I reduce this to 1 meter, we reduce this to 1 meter. Now we'll run again. What happened is, going to the graph again, then the distance is over roughly 1,100 meters. We can also see it again. Look at it, 1,100 meters. 1 meter per second implies that there will not be as much vertical mixing. Then the plume will travel farther and hit the ground. And if you have 3 meters, it will mix more, it will mix faster, it will hit the ground sooner vertically, it expands more. So please look at the assignment. You have to do a few things, modify the stability class, and also you will modify, you have to go back to input, have to modify stack height, run stability class F with 2 different wind speeds. You have to do for 100 meters, you have to do 1 meter. That's it for now. Thank you very much.